Okay, so the problem we'll be looking at gives us three different compounds made up entirely of nitrogen and oxygen. And for each one, they give us the amount of nitrogen as a percentage in each of those different compounds. And the first one they give us is laughing gas, which has a percentage of 63.65% nitrogen. And they give us colorless gas, which has a percentage of 46.68%. And finally, they give us brown toxic gas, which has a percentage of 30.45% nitrogen. And we are asked to prove how these percentages prove or deny the law of multiple proportions. The law of multiple proportions states that when two elements form more than one compound, different masses of one element that combine with same mass of other elements are always in the ratio of small whole numbers. So looking at this, it's hard to put this in a ratio when it's percentages. So first, it's easy if we just make it out of 100 grams. That each one of these, the laughing gas, the colorless gas, and the brown toxic gas, are out of 100 grams. So looking at that, we just change this to 63.65 grams of nitrogen and 46.68 grams of nitrogen and then 30.45 grams of nitrogen. And going from there, we have to make one of the whole numbers a whole number, obviously. So what you do is you take the 63.65, or the amount of grams of nitrogen in each laughing gas, and you take that and you minus that by 100. Therefore, you can get the amount of oxygen in each solution. So if you take the laughing gas and you do 100 minus 63.65, you'll see that we have 36.35 grams of oxygen. And for the colorless, do the same thing, 100 minus 46.68 equals 53.32 grams of oxygen. And then 100 minus 30.45 equals 69.55 grams of oxygen. Then, to get it to have a whole number, we just take those numbers and we divide them by each other. So this one, you do 63.65 divided by 36.35, and you get 1.75 for every 1 gram. Same thing here, you do 46.68 divided by 53.32, and you get 0.88. Oopsie, 0.88 divided by 1 grams, and then 30.45 divided by 69.55, you get 0.44 grams. So there, that proves that you have the whole number. You have each one of these oxygens as a whole number, 1 gram, and then you have as much nitrogen for every whole number there. So there you have it.